Hey YouTube, got something sort of interesting here that you might appreciate. There was a question on a test years ago when I was in high school about, given a device that's designed to run alternating current and direct current, which one will it run better on? And this device here, this Oster Model 412 Series B Classic 8 blender is one such a device. Even today, there's a lot of devices that fundamentally can run on direct current at high voltage, but except for their electronic speed control they might have. No one uses high voltage direct current anymore, but there was a time when it was available in households. So they used motors in these appliances. They're called compound wound, series wound, or series compound. And they will run on alternating current or direct current. The starter motor in your car will, if it was disconnected from the rest of the electrical system, would crank on 12 volts alternating current in addition to 12 volts direct current that it does crank on. So that's just a characteristic of the motor. And it worked out well because you could have one motor work on both currents. Well, which kind of electricity, alternating current or direct current, does the blender run better on? We're going to see. This to the right over here from the blender is a sort of a kludged together setup. Auto transformer that can raise or lower the line voltage, gives AC output still, just changes the voltage. Running over to that black item over there where the white wires and the black wire go is a full wave bridge rectifier. Out of the rectifier comes direct current, but it goes to that capacitor laying on its side, about a 600, 700 microfarad capacitor to smooth the current, which you really don't need to do in the case of a blender, but I put it there anyway. It's normally something you'd use for sensitive electronics. And then a voltmeter to measure the voltage appearing at where you plug the appliance in. Old Simpson wattmeter, which I'm not going to use for this, it's connected, but it's not going to be part of the video. And a switch that can, with the flip of a switch, I can switch between alternating current and direct current, because there's a bypass for the alternating current to come directly to the switch, and the rectified direct current after the smoothing capacitor to go to the switch also. So either one can be shuttled to the outlet plug. So let's see something. On direct current, the switch is set for direct current now. Voltmeter is set to direct current also. And here is the blender. I'm going to raise the voltage until the blades just start turning. There they go. And we're at 11 volts direct current. Now watch when I switch to alternating current with the flip of the switch. I go here, so the blades stop. Got to switch the meter to alternating current to measure the alternating current voltage. And it's at about 11 volts AC, but they stopped, right? And then what do I have to do here? I'm going to increase the voltage of the auto transformer until the blades start turning again. Still going. There they go, just start turning, and at 72 volts. So that shows that the alternating current is not as good about furnishing a magnetic field, because these blades only turn when there's enough magnetism to overcome the friction. At this point, there's not much load because of the water in the jar, but just to overcome the friction of the motor. We'll repeat that. If I switch to direct current at first there's no good reading, but watch what happens when I switch over to direct current. And it's 93 volts. And I pull back to the 70 volt level with the alternating current. So just to get the blades to start moving, it took 70 volts AC. On 70 volts DC, you can see what's going on. So there's quite a bit of a difference. Turn that off. So the bottom line is that if you know a little bit about electric motors, these kind of motors have a lot of wire in them. These they're not like a range. You can't run range hoods washers, dryers, dishwashers, those kind of motors, refrigerators with direct current. Those are called induction motors. These motors that can run on both have two big coils of wire. One that's stationary, grounded to the motor frame, which is bolted to the appliance frame, and the other is the armature, which can rotate freely. They, to direct current, only present resistance. For alternating current, they present the same resistance and something called reactance. And the reactance is, in this case, inductive reactance. There's capacitive reactance and inductive reactance. The two together can net out to zero if they're balanced. But these have quite a bit of impedance, total impedance to the electric flow. That's why the current flowing through the motor is so much less on alternating current than it is on direct current, as evidenced by the amount of voltage needed to start their blades turning, and as you saw, the performance difference between the blades between the motor running on AC and DC. And that's just the way it is. So alternating current is, there's another feature about alternating current that even adds to it slightly, about 10%, 11%, is that you get, for the same heating effect as a direct current, say 120 volts DC, you get 120 volts AC has the same heating effect, but the charge transport of 120 volts AC is only as good as 108 or so volts DC, which means that you pay a penalty in extra heat versus charge transport. Now, charge transport is how many electrons per second or current charge is moved in unit time or amperes. And for metal plating, there's certain things where battery charging, and things where the charge transport's the important thing. You're at a disadvantage for alternating current when it's rectified. You get the same heat as the full value of DC heating, but your charge transport's lower by about 11%. So it's, which isn't much. Obviously, we saw a difference way more than 11% here, but it's just a contributing factor. It's called the form factor. It is the heating, the power versus direct current, which has a form factor of 1.0. It is the heating effect divided by the charge transport. For alternating for sine wave power, it's about 11%, 1.11, which means that the heating effect, or in the case of alternating current, which is square root of 2 divided by 2, is versus 2 over pi gives you 1.11, that one quantity divided by the other. So anyway, just some interesting stuff that was brought up years ago in a class in high school about universal motors, which one do they run better on. It just demonstrates, yeah, they run better on DC. Let's do one more test with 120 volts DC versus AC. See what happens. So on direct current, we're going to go to 120 volts. I'm going to switch down to alternating current. You notice that I need to make an adjustment because it's only at 90 volts. You can probably hear that it doesn't run quite as well on 120 volts AC. So here's 120 volts AC going on. If I go to direct current right now, it's going to speed up a lot. So I'm going to reduce the voltage first. Move the meter to direct current, move it to, and that's 120 volts right there. So, yep, confirms that the coils do not like the alternating current as much as the direct current, which is fully in line with electrical theory. Hope that was something interesting to you. Something I've been wanting to do for a while, just to jig up a setup to get high voltage direct current out of the wall, or rectify it and smooth it for use. So, no real advantage in in a real practical sense for using alternate direct current, having a setup this complicated to run direct current high voltage. Oh, one thing about this unit, this blender, if you ever find a chance on eBay to get a Classic 8 that has this style knob, it's cool. It's really good model to get. The stir setting is simply the line voltage, whatever it is coming in through a resistor to the motor. It's very slow setting for stirring. Once you switch off of that stir setting to the governed speeds, it goes to, the motor is controlled to have a certain exact RPM up until the point that the motor's capability is exceeded to deliver the RPM for the load. And it's the same kind of governor, good Watchworks style mechanical governor, true speed governor that the Sunbeam Mixmaster and the K5 and K45 KitchenAid units use. It has a mechanical speed governor. So it's rare. It's rare. It's not electronic control. It's mechanical, flyweight governor mechanical. So just in case you can get one of these for like 60 bucks on eBay, maybe 100 at the most. But if you ever wanted a high quality appliance, get stuff made in America from the 60s. Don't buy the Chinese stuff that's like Walmart or whatever. It's just a waste of money. All right. Thank you very much for watching. Hope you enjoyed it. Bye-bye.